Example 7. The height of tide can be modeled by a sine function or a cosine function. And we have the low tide occurring at 1:30 at 4 meters and a high tide occurring at 1 o'clock at 12 meters for 1300 hours. So I've drawn that here. We have our low tide to the left and our high tide to the right. And the times are along the x-axis. And we need to determine the equation of the function. So we need amplitude, vertical shift. We need the period to calculate b and the horizontal shift. So we're going to use a cosine function. So we're going to make this horizontal shift fairly easy using the cosine function. So the first thing I'm going to do here is calculate the amplitude. And the amplitude is half the distance from the top to the bottom. So y max minus y min. So 12 minus 4 divided by 2 is going to give us an amplitude of 4. I can also just count up and down from the middle here. So if I've drawn the diagram accurately, I can see that that's 4 meters of amplitude. The vertical shift is going to be the average value. So we add the two y coordinates and divide by 2. And we end up with an average value of 8. So that represents our vertical shift. For the period, what I've drawn here is half the period. So if I take a look at the distance along the x-axis, so to find this distance, I subtract. So I'm going to end up with 13 minus 1.5. That represents the distance, which is half the period. And so that gives me 11.5. And being half the period works out to be double that, or 23 hours. So my t is 23. That makes the b 2 pi over the period, which is 23. So now when I write the equation, I'm going to use a cosine graph. So I'm going to use an upside down cosine graph. So I'm going to use this as my starting point here. And to do that then, I'm going to have y equals, it's upside down, so I'm going to have the negative. But everything else is the same. So 4 cosine, the b value is going to be 2 pi over 23. My horizontal shift in this case is going to be at 1.5, so it's going to be 1.5, so it's going to be x minus 1.5 hours, and then the vertical shift is going to be plus 8. Okay, so that represents the starting point at the bottom. Now I can write an equivalent cosine function using that position there, and that means that my graph is a positive cosine. So I just end up with 4, and everything else is the same. Cosine 2 pi over 3, 2 pi over 23, x. In this case, though, the shift is going to be 13, and then the vertical shift is going to be plus 8. Okay, so that's going to give us a horizontal shift of 13. And then finally, I could also do this using the sine, which means that middle position represents the starting point of sine. So I can write this as 4 sine of 2 pi over 23. The shift position is going to be halfway between the min and max along the x-axis. So I add those two together and divide by 2. So I get 7.25. And then the same vertical shift.